So how do we create low energy electromagnetic waves? Well, we take an electron and we wiggle it back and forth. This will create low frequency radio waves or microwaves. Remember that microwaves have a wavelength of a few centimeters. So all we need to do to create waves like this is take electrons and wiggle them back and forth very fast. It turns out that we're not able to do this for higher energy electromagnetic waves simply because we can't shake the electron fast enough. So this means that we can't vibrate them fast enough to produce higher energy EM waves or electromagnetic waves. So if we want to create light or X-rays or gamma rays or something else like that, we'll have to find a different way to do it. Higher energy waves like light and X-rays are in fact also produced by electrons, but in a different way. What happens is that an electron, while it is still inside an atom, will change the amount of energy that it has. This is more sort of quantum mechanics that we're getting onto now. But for now, all you need to know is that the electron only moves inside the atom. It does not, in fact, wiggle back and forth in a conducting antenna, like for a radio wave or a microwave. Gamma rays are produced differently to either of these other methods, and they are, in fact, a certain type of nuclear radiation. A nuclear reaction is a reaction that only takes place in the nucleus of an atom. So without the atom interacting with other atoms, only the nucleus acting. Of course, nuclear radiation is responsible for building things like nuclear power plants or nuclear bombs. And so gamma rays are one way that the nucleus of an atom can emit energy. Which of these options has the most energy? Now we have a couple of options here, so let's go through them. We'll start off at the bottom, radio waves. Now it turns out that anything below a certain frequency or above a certain wavelength, if you want to put it like that, is counted as a radio wave. So these have the least energy because they have the least frequency. Anything with a wavelength of more than a few centimeters is classified as a radio wave, no matter how long its wavelength may be. Alright, the next most powerful is microwaves. These have more energy than radio waves generally, but in fact low energy microwaves, that is microwaves with long wavelengths, are exactly the same thing as radio waves with short wavelengths. So these might be on the neighborhood a centimeter or two. You could either say that an electromagnetic wave with a wavelength of 5 centimeters is a very high energy radio wave or a very low energy microwave. Alright, moving up to higher energies and making a few jumps and bounds, we'll end up at ultraviolet light. Now in between microwaves and ultraviolet light, we have infrared light and visible light, both of which have more power than microwaves but less power than ultraviolet light. So ultraviolet light has more energy than infrared or visible light, but it doesn't have the most energy out of all these options because there's one that I haven't got to. And that is, of course, X-rays. The only electromagnetic waves with more energy than X-rays are called gamma rays. And that's not one of the options. Our only answer then is B, X-rays. Remember though, that if we get a very high energy X-ray, it's pretty much identical to a very low energy gamma ray.